VSTAR Systems last year, and we provide end-to-end system integration services for commercial and government clients. Or as somebody pointed out to me before, I'm kind of like a general contractor for unmanned systems. We provide acquisition support and project management and systems engineering and development services for unmanned systems. And I started my career with Northrop Grumman. Actually, my first career was actually with the Navy. I was in the Navy for about 8 years, but then went over to the dark side, to industry, and started my time at Northrop Grumman on the MQ-8V Fire Scout aircraft. I was a flight test engineer and a payload operator. Logged quite a few hours on this. This was actually a naval helicopter, able to carry about 750 pounds of payload. And before long, I found myself on the Global Hawk on the Air Force version, working on system integration, specifically on the payload side, radar and signal intelligence. And I ticked somebody off and they made me chief engineer of the Block 30 variant at Northrop Grumman. And so I was in charge of the entire Block 30 variant of this aircraft, the development, production, and sustainment efforts for Northrop Grumman. And I don't know if you're familiar with the Global Hawk aircraft. It's a pretty amazing piece of machinery. It flies at 60,000 feet. The duration is about 35 hours while carrying about 3,000 pounds of sensors or other equipment, all while being flown by an operator in California. The aircraft is somewhere in Afghanistan via beyond line of sight links. Starting in 2011 or so, we started fielding this aircraft all around the globe, multiple locations. So we were very excited about our technology that we provided. We had the aircraft, we had EOIR sensors, SAR radars, and as soon as we went operational, we learned that that really did not matter to the customer. Our real customer was the guy on the ground in Afghanistan. He did not care about what cool radar package we had on there. He cared about, what do I do with this? When I'm in a firefight, what imagery do I get? How does that help me at the end? And with commercial side, I feel we're gonna see the same exact thing. We're building the technology right now. We're building quadcopters, we're building LiDAR sensors. That farmer on the ground, when his problem is 10% of his crop is dead at the end of the summer, that is his problem. That is what he's trying to overcome. How we do that is a different answer. And you have to provide a solution for that guy rather than just the technology to come up with his own solution. And I've seen that a few times today already. And so, really, the technology does not always equal the solution, or very rarely actually. You have to consider other factors. So, first, you have to really understand the problem. And as Einstein once said, if he had an hour on a problem, he would first spend 55 minutes on that problem, and then only 5 minutes to come up with a solution. Same kind of concept. So you have to start with the why. What's the motivation behind them? For that farmer, it's his field. Why is he losing the crops? What is he really trying to achieve? Is it water damage? Is it a pest? And then you move into the how. How are you going to solve that problem? That's the process question. Finally, at the end, you're going to go with the what. What technology can solve that problem? But you have to go through those first 2 stages before you really can come up with anything. So one of the fun things that we always got to do were concept of operations. How is it going to look like when it's fully operational? And this is one of the fun, like I said, the fun things that we get to do ahead of time is how will it operate? How does it all connect? You have beyond line of sight. But while you're doing that, don't forget all the other things. Product life cycle, the R&D phase, the production, the fielding, the support, disposal. And a lot of times that is forgotten. Again, we heard earlier, Nancy Egan, the regulatory side. How is the regulatory side going to affect you? Supply chain. If you ever worked in the military, diminishing marginal supply, DMS. It might be that your technology, by the time you field it, is already old again. How are you going to upgrade that system again? How are you going to get new upgrades out there? Who is going to do that? Maintenance. Who's going to maintain the system? Who's going to be the guy that's actually touching the aircraft? Who do you have to have in place to maintain the aircraft? Who's going to do the repairs? Is it the guy, the farmer, supposed to change out something? Or do you send the whole thing back? The training of it all. How do you transport it? And then interoperability is one of those things that's often forgotten. And if you look across the entire product life cycle, disposal, another one of those that very rarely thought about. How is it going to be disposed of at the end of the life cycle? If you have a system out there for 10 years, do you use some kind of technology that's very hard to get rid of again? Batteries. That is, going to be a problem for that guy. And then when you think about that overall, what's the budget? And what I've found a lot of times when I talk with smaller UAS operators, I like to ask them about their reliability of their system. And not very often do I get an actual answer where they can tell me, my aircraft will last 2,000 hours. But the guy that's looking for a solution, you have to be able to tell them, well, my system is going to last 2,000 hours, so if you want to keep it for 10 years, here's the stockpile of material you're going to need. Here's the training cost that it's going to cost you. What is the overall life cycle cost for them? And then at that point, he might say, you know what, considering all of that, it is way too expensive to really implement this commercial system right now. There might be a cheaper solution for them, but they really don't know that right now. So overall, you have to really consider all 3 of those: the technology, the processes involved, and then the human aspect. And so in review, focus and understand the problem. Ask the why, the motivation, the how is it going to be done, what's the process behind it, and finally the what technology will solve it. Consider that entire life cycle, and don't ever forget the human in the system. My presentation.
That was it. That was good. Any questions?
Any questions for Andy? Or is everybody just ready to get out of here?
Ready to get out of here.
Have a beer. All right, big round of applause for Andy.